So, lesson 23. We are going to talk about trig functions of n theta. So when it's not just a trig function of theta, but there's a number in front of the theta. Then we're also going to look at graphing conics on a graphing calculator.
Looks like it says trig functions in delta.
That would be n theta. And then representing some number. Okay, you call a no. Trig functions of no, then. Okay, so the idea here, looking at example 1, solving something such. Realize I don't need to have that in. Okay, so if this, what do you know how to solve right here?
There's a sine theta.
Right. So let's go through off to the side here. If this was sine theta equals 1/2, okay, what would you know about your answers? Okay, we'd have to think about our quadrants, right? So it's wherever sine is positive, and where is sine positive? All students take calculus, so it's going to be in quadrants 1 and 2. Quadrants 3 and 4 are going to be irrelevant here. But we do know we need to talk about quadrant 1 and quadrant 2. Okay? More thoughts? Can you tell me what your solutions are? When does sine equal 1/2? At what? 60 or 30, I agree. Let's get a little more specific though. And it's 30? If you go for that chart, the chart in my brain, the top row, the first column is sine and the top row is 30. And that first box is 1/2. Okay? Now, 30 is one answer. So that means that is our answer over here. 150? Why 150? Yeah, it has to be 30 above 180. So 180 minus 30 is 150. Okay, because those are our answers in our two positive quadrants. Right? Okay. Now, what this actually said is sine 3 theta. So what we've got to think is in terms of, how do I want to say this? 3 theta. So if we said sine of theta is 1/2, we came up with answers of 30 and 150, correct? So the idea here then is 3 theta. You can take this 3 theta and set equal to 30 degrees. And we can find the actual theta from there. However, because it's a 3 theta, this changes things a little bit. Okay? When you guys gave me two answers of 30 and 150, that's because the range of answers is from 0 to 360. So that's once around our unit circle, yes? Because this is a 3 theta, you need to multiply these by 3. And let's look at what that changes. So now my range becomes still 0, right? 3 times 0 is 0. Less than or equal to 3 theta. Less than or equal to, what's 360 times 3? A big number. 1,080. Or, what's easier to think of probably is if it's 3 times 360, that's no longer once around the circle. That's 3 times around the circle. Which means 30 degrees happens the first time you go around the circle. And then that 30 degrees happens also the second time you go around the circle and the third time we go around the circle. We also have an answer here. Remember 150? Where 3 theta is 150. 150 is the first time around the circle, and then you're going to have what? 2 more times around the circle. How many total answers are we racking up here? There are going to be 6 solutions to this problem. Because what happens is that 3 theta means you're going around the circle 3 times. Okay. So, you want to get our first sets? Let's see, how do I want to do this? Okay, so we already said 3 theta equals 30 and 3 theta equals 150. You do your basic easy math, right? If 3 theta equals 30, then theta is 10 degrees. That's one answer. You can do the same thing down here. If 3 theta equals 150, then theta is 50 degrees. We have 2 of our 6 answers, right? Okay. How I get the others. If you look over here, it was 3 theta equals 30. Well, what is 30 the next time you go around the circle? Because it's 30 plus, I'm going to write it out as, it's 30 plus 360, right? Because 360 degrees around the circle. So this equation you're solving this time is really 3 theta equals 390. If 3 theta equals 390, then what is theta? 130 degrees. Okay? And how do you want to think about the other answer involving 30? There's 2 different ways I could look at this. I'm kind of curious what you guys say. Add 360 again. So we're adding 360 to the 390. Does that make sense? The other option is to say, okay, it's 30 plus 2 times 360. I don't know which one are you guys more comfortable with. Add 360. I mean, that's what I would do is I'd take, okay, where was I last at? I was at 390 and I added 360. So I would have said 390 plus 360. And so 390 and 360. $750. And so you divide, and theta becomes 250. Again, if you don't like what I did up there, another way of doing the 390 plus 360 would have just been to do 30 plus 2 times 360. Okay, so that's the same thing, if that makes your brain like it better. Okay. And I've got 4 answers. I've got to also do the same process with the 150. So if it's 150 the first time around the circle, then the next time it's 150 plus 360. 150 plus 360. 510. And then if you divide by 3, theta is 170 degrees. And lastly, what are you guys going to do? $510 plus 360 is what I was guessing you guys would say. So 510 plus 360, 870. Divide by 3 and we have 290 degrees. Valid point, I guess. I was just trying to make sure. My brain's trying to comprehend. That always works, correct? And I think it does. That would be the shortcut. This is the why it works. Does that make sense? So, and if you wanted here, this would have been doing what? The 150 plus 2 times 360 if you liked that better. So, okay, 6 answers, yes? And the shortcut to knowing there were 6 answers is we actually found 2 answers originally, right? Since it was 3 theta, 2 times 3 is 6. Okay? Let's try another one of these. Tangent of 4 theta minus radical 3 over 3 equals 0. And it's on the interval from 0 to 2 pi. You ready? Okay. What are the pieces you want to talk about? Guess maybe start with what should we do with that equation? Okay. Add that radical 3 over 3 to the other side. So that this actually reads tangent of 4 theta equals radical 3 over 3. That's the equation we're solving. What is that going to change my interval to? You're going to multiply everything by 4 since it's 4 theta. So then we're talking on the interval from 0 try this again. Oh my gosh. From 0 to 8 pi. Okay. Guess of how many solutions I'm going to have? Likely 8. I guess we can't really confirm that till we see how many just tangent answers there are. But you're heading the right idea. So what's the similar question we need to ask ourselves? When does tangent equal square root of 3 over 3? So she says what? Pi over 6? 30 degrees? I didn't make the chart on the other one. Should I make the chart just for review? My chart goes sine, cosine, tangent. 30, 45, 60, or in other words, pi over 6, pi over 4, pi over 3. Yes? That's my chart. Top left corner, 1/2. So sine of 30 is 1/2. That means cosine of 60 is also 1/2. Cosine of 30, radical 3 over 2, which means radical 3 over 2 down here. Not that we need the 45s, but radical 2 over 2. You got that memorized so you can do that? Now, tangents is sine over cosine. So if we ignore the 2's, this is 1 over radical 3, but that rationalizes to be radical 3 over 3, right? Right here, they divide to be 1, and right here, square root of 3 over 1 just becomes square root of 3. So, first answer is pi over 6. All students take calculus. So, what other quadrant do I need? Quadrant 3. So right here we had pi over 6. What about quadrant 3? What was it? 7 pi over 6, because 180 is pi, right? So pi is 6 pi over 6. If you go a little bit past it, that is 7 pi over 6. So, as expected, we came up with 2 answers. Since this was 4 theta, 2 times 4 is going to make us have a total of 8 solutions. Egads, right? This one is a little bit more tedious because we have to work in radians. Okay? And I know radians are the least favorite to work in because it means fractions, but that's all right. We're going to make it happen. Okay? So, what are the initial 2 we're setting up? 4 theta equals pi over 6, and 4 theta equals 7 pi over 6. So what do you want to tell me to do to solve for theta there? Okay, he says multiply by 1/4. Is that probably a little bit better than the alternative of dividing by 4? Okay, it's the same thing, exactly. But if your brain first went to divide by 4, think, oh, then I have to do fraction divided by 4, so let's multiply by the reciprocal, so 1/4. Nice part about it is it makes the fractions not horrible. What's my first theta going to be? Pi over 24. Do you want to do the one below it? If it's 4 theta equals 7 pi over 6, instead of dividing by 4, multiply by 1/4, we end up with theta equals 7 pi over 24. Okay. What do we have to do to find the next ones? You're adding 2 pi, right? It was adding 360. Now we're adding 2 pi. So it's 4 theta, and it was pi over 6. When we say add 2 pi, what'd you say, Mallory? Yes, we are essentially going to be adding 12 pi over 6. So it is 2 pi, but my brain needs to think 12 pi over 6. So 4 theta equals, what, 13 pi over 6? And officially, what do we have to do? Multiply it by 1/4. And so then we end up with 13 pi over 24. Okay, should we keep working our way across in the top row now?
Sure.
And obviously you'll find the shortcuts and things along the way, so. Okay, what's my next one? $13 pi over 6 is what we ended with. So it's 13 pi over 6 plus 12 pi over 6. And 13 pi over 6 plus 12 pi over 6 is 25 pi over 6. And if it's 4 theta equals 25 pi over 6, then we need to multiply by 1/4. So, 25 pi over 24. Am I done on the top row? We got one more, right? Because we have to go 4 times around that circle. So, 4 theta equals what? Okay, she says 37 because you're doing 25 plus another 12. So 4 theta equals 25 pi over 6 plus the 2 pi, so plus the 12 pi over 6. I agree, that is 37 pi over 6. Divide by 4, which is multiply by 1/4, and so theta is 37 pi over 24. Am I done? With the top row, okay. Logan's looking like you might want to be done, but we're not going to let him. Okay, so bottom row. We started with 4 theta equals 7 pi over 6. So if it's 7 pi over 6, then we're going to add the 12 pi over 6, which puts us at 19 pi over 6. And you know the connection, right? Multiply by 1/4. And theta is 19 pi over 24. Continue along. This time, let's see, we left off with 19 pi over 6, adding 12 pi over 6, 19 and 12, 31 pi over 6, multiply by 1/4, and I've got 31 pi over 24, and one more. 4 theta equals, let's see, where did we leave off? 31 pi over 6, plus we're adding 2 pi, so we're adding 12 pi over 6. 31 pi over 6 plus 12 pi over 6 is 43 pi over 6. Multiply by 1/4. 43 pi over 24. It is, exactly. And again, you know, I'm guessing Logan noticed that the difference between the top row and the bottom row is a difference of 6 pi over 24, right? So, you know, there's differences. Notice all my denominators ended up being 24 because they were 6, multiplied by 1/4. There's shortcuts you can take. Obviously, I wrote out the work just so you have it to, you know, this is the why. Okay, this is the whys, this is how it works. I know you guys are going to create some of your own shortcuts. Just be careful that they work, you know. That's the key there. Okay. Got it? Because we're going to change modes. Use a graphing calculator. Graph the ellipse defined by x squared plus 2x plus 4y squared equals 15. What's the key?
Get that y by itself.
Y by itself if we're going to use our graphing calculator. So, solve for y. Starts off x squared plus 2x plus 4y squared equals 15. What is step 1? Subtract those two x terms over. So then it's 4y squared equals, I'm going to write 15 minus 2x minus x squared. My brain knows I'm just going to be plugging this into the calculator. So does the order really matter here? No, because I'm not going to have to try and factor. And then we're going to divide by 4. Again, I'm plugging this into the calculator. So if I think in terms of plugging it into the calculator, it'd be easiest to do the 15 minus 2x minus x squared all over a 4 rather than typing 3 separate fractions, right? And then what's the last step? Square root. What about the square root? plus or minus. So you can do, again, it's about plugging this into the calculator. So you can do it just like that. Plus or minus the square root of 15 minus 2x minus x squared all over 4. If you wanted to, what do you know about the square root of 4? It's 2. So you could say plus or minus and just put the square root on top of 15 minus 2x minus x squared. And then all just over a regular 2. Kind of a personal choice there. What do you want to plug into the calculator? What's the key when you put this in the calculator? Okay, you got to do 2 of them. So in y1, I can put the positive one, right? Square root of 15 minus 2x minus x squared. If I use my slightly simplified, I could put over 2, not in the radical. Do you remember the shortcut? Yeah. You can make y2 just the negative of y1 when you plug it into the calculator. Or you can take the whole thing out. It doesn't matter. Did you guys graph it? See what it comes up to be? So there I have my y1. Then I can say the negative, y2 is the negative of y1, which Logan said we found it, yep, in the F4 menu. And you can say that. Okay? We're supposed to be graphing an ellipse. Does it look like it panned out?
Yep.
Yeah. I'm curious. Okay. Didn't make a whole bunch of difference. I was curious. It was this class we talked about the zoom square thing, wasn't it? And so I was curious what the zoom square made it look like. Okay. Questions on that one? I don't even have. I mean, you could sketch the, when it says, if it says graphing like that, on work I'd expect to see it solved, and then you could sketch an ellipse. I don't even have an ellipse sketched in my notes, so I don't know why I didn't at least sketch it. But I guess I could real quick if I want. And when I sketch an ellipse, I just try and eyeball. Looks like it goes through 3 there. Goes through the 2s on there. That's why I don't sketch ellipses. Yuck. That looks pretty bad. I don't even know what that looks like. I just cannot. I can't sketch ellipses.
Mine looks different, but equally bad.
Okay. Bad, but a different bad, huh?
Yeah, yours got weird at the third or fourth one.
Mine just looks like a
mine
weird
got
color.
weird in the fourth one.
Oh, well. Okay, one last one. Use a graphing calculator. Graph the conic defined by blank. Notice it doesn't tell me this time what it is. Last time it told me it was ellipse.
It's got 2 different ones.
It's a circle. Yeah. It's like it's one of these 4 things.
Okay. And how do we know it's a circle? Good review. Yeah, x squared and y squared, both positive, both coefficients of 1. Okay, so step 1. Not right now. If we're trying to solve this for y, we need to get y's on one side, everybody else on the other side. which means I'm going to keep y squared minus 2y on that side. I'm going to leave a blank, a space. I'm going to move everything else, so I still have the 4 minus the 4x minus the x squared. Okay. We have to be able to get this to say y equals. If you have a y squared and a y term, you can't just magically get it to be y equals. Excuse me. I left a blank because I was hinting that we're going to complete the square. What completes the square of y squared minus 2y? What? Plus 1. It's a plus 1 because, remember, b is negative 2. Negative 2 divided by 2 is negative 1. Negative 1 squared is plus 1. If I add 1 on the left, add 1 on the right. Your next step after you complete the square is always to factor. That's the whole point of completing the square, because we want to factor. Y squared is y. What's the square root of that c term, that 1? 1. And that middle term is a minus, so it does make it y minus 1 in the parentheses. On the right, you can do some cleanup. 4 plus 1 is going to make this a 5 minus 4x minus x squared, or you can reverse it if you want. Now what? Okay. He says he's got it all at once. Take the square root and add 1. So if I just take the square root, it's y minus 1 equals what? The square root of there, but it has to be plus or minus. So y minus 1 equals plus or minus that square root. And then, if you add the 1 over, I like to write it as 1 plus or minus the square root of 5 minus 4x minus x squared. And you ready to punch into the calculator?
Look at that circle.
Does yours look like mine?
I've got mine in the square thing.
Yeah, I had mine square, but
Okay.
I changed it back to standard, so.
Okay, so if we change it to the square one, so it will hopefully actually look like a circle. Okay. I do have mine typed in right, don't I? It's a little more lopsided than I would have expected.
Mine's lopsided too.
Okay.
That's how mine did.
Now, could you use the whole y1 equal y2 equals a negative y1 on this one?
Yeah.
No, because it's that 1 plus and 1 minus. That 1 doesn't change signs,
Yeah.
so you can't actually use the negative thing. Okay. So yeah, if you want it to look like a circle, we've been talking about using z square to make it look like a circle. And then if you sketch this, I don't know. Do I want to say good luck?
Yeah, it's kind of hard to do.
You would think it'd almost be better if you draw a circle and then try and draw the axes in it. I feel like.
Draw those. It's not-
That's really good.
Just insert circle on graph.
Do we have to present our things to government?
But it's not
Presenting
new.
it?
It's not
Oh, you guys can't see my yucky circle. And to stop the recording, and you're gonna have to show it. But
Yeah, not
Well, I got my dots in the right part.
see, that's the thing. I draw the dots, and then I try and draw the circle, and it doesn't work. Okay, you guys have the idea.